Our digital world is going through this massive shakeup, and well, you're right at the center of it. And that's not some metaphor. The internet is literally physically moving closer to you. It's changing its shape just to get faster. Okay, let's dive into how this incredible shift is building the future of speed.
All right, so here's the game plan. We're going to start with the universal enemy, lag. Then we'll meet the technologies designed to finally beat it. We'll see how they all come together to form a strategy, watch it play out in a super high-stakes race against time, and then at the end, we'll understand why this whole shift to a local internet is going to change everything.
Okay, first things first, the lag problem. That super frustrating moment when your video call freezes right in the middle of a sentence? Yeah, that. It's so much more than just an annoyance. It's actually a fundamental problem of physics, a challenge that's all about the sheer distance our data has to travel.
I mean, we've all been there, right? You're in the middle of a huge meeting or you're about to score the winning goal and bam, everything just stops. That delay, that maddening little gap between when you do something and when it actually happens on screen, that's the core issue we're talking about. And it's a physics problem that needs an architectural solution.
So this enemy we're talking about, it has a name, latency. And honestly, this pizza analogy just nails it. Your data has to travel a real physical distance through actual cables buried under oceans and stretched across entire continents. And the farther it has to go, the longer it takes. Just like with a pizza, when it comes to data, timing is absolutely everything.
So how do we fix this? I mean, we can't exactly change the speed of light, right? But what we can do is radically shrink the distance that data needs to travel in the first place. And that brings us to the modern toolkit for building a way, way faster internet. For decades, the cloud was the answer. And these massive data centers are absolute powerhouses, incredible for storing and processing just unbelievable amounts of information. Think of them as the great national libraries of data. They're vast, they're powerful, but they're often hundreds, if not thousands of miles away from you.
Now, to get more flexible and not get stuck with just one company, businesses started using a multi-cloud strategy, so they'd pull services from different providers. But, and this is the key thing to remember, this is all about having choices, not about speed. It doesn't actually solve that core problem of distance.
And this is where the star of our show comes in, edge computing. This is the big idea. Instead of having one giant faraway library, the edge creates thousands of little local branches and pop-up kiosks right in your city, in your neighborhood, sometimes even in the very same room. So when you put them side by side, the difference is just crystal clear. The big, centralized cloud is still the king for those heavy, non-urgent tasks, like archiving all your family photos. But the distributed edge, it's built for one thing: instant action. For anything that needs a real-time response, the edge wins. Every single time, because proximity is power. But here's the twist. This isn't a battle of cloud versus edge, not at all. The real genius is in how they work together to form this powerful new strategy for speed. This quote just nails the whole philosophy, doesn't it? Every single piece of this new architecture, every component, is designed to do this one simple thing: collapse the space between a question and its answer. You can think of the edge as this rapid response team for your data. You've got CDNs, which are basically like local warehouses that store popular videos and websites right near you. You have edge locations that the big cloud companies are building in major cities. You even have 5G towers that can now compute things, not just transmit signals. They all work together, like a coordinated network ready to act in an instant. Okay, so here's the big idea, the way to think about it all. The cloud, it's still the central brain, handling all the heavy lifting and storing massive data sets. But the edge network, that acts like the body's nervous system, a lightning-fast web of reflexes that can react instantly without having to wait for instructions from the faraway brain. All right, theory is great and all, but let's make this real. Let's look at a scenario where this architecture isn't just a nice-to-have, it's literally the difference between winning and losing millions of dollars in the blink of an eye.
So, welcome to the world of automated financial trading. An algorithm in London spots a tiny, fleeting opportunity on the New York Stock Exchange. The very first firm to act on that signal gets the profit. The second firm, they get nothing. It is the ultimate test of low latency.
Now just look at these two paths for the exact same trade. In the old model, that signal has to travel all the way across the Atlantic to a cloud server, get processed, and then travel all the way back. By then, the opportunity is ancient history. The result? Bid missed. Too late. But with an edge computer right there in London, the decision is made instantly. The result? Bid one. Simple as that.
And the difference? About 80 milliseconds. That's literally faster than you can blink your eyes. In our daily lives, that might seem like nothing, but in these high-stakes games, finance, online gaming, remote surgery, 80 milliseconds is the entire universe between success and failure. That's the value of the edge. And look, this isn't just some fancy trick for Wall Street traders. This fundamental re-architecting of the internet is what's finally making all those technologies we've been dreaming about for decades actually possible. I mean, just take a look at this list. A self-driving car can't afford to wait for instructions from a server 500 miles away to decide whether to hit the brakes. It needs to make that decision in the car right now. A surgeon controlling a robot from across the country needs feedback that feels absolutely instantaneous. All of these incredible futures depend entirely on the zero-delay world that the edge creates. And that's really the big takeaway here. This whole move to the edge is the essential groundwork. It's like we're installing new digital plumbing and wiring that's going to support a world that doesn't just store information, but can interact with us intelligently in real time. Which kind of leaves us with this pretty wild thought, right? For decades, we've thought of the cloud as the center of the digital universe. But as our technology demands more and more instant local intelligence, is the center of gravity shifting? Will the fast, distributed, and responsive edge ultimately become the most critical part of our world's infrastructure?